All right, and I think we are live with LRVS 2024 EMEA edition. So I know a lot of people are very, very excited this morning. They've been waiting a long time for this and to see EMEA because I know our EMEA region is very, very excited and they usually have a lot of things going on and they want to, make sure they get as much information as possible and just, enjoy what they can. So I'm gonna wait a little bit for the LinkedIn live to start and YouTube as well. YouTube has started, LinkedIn is coming in, and I know we have a lot of people just joining us very quickly this morning. And for those of you who are joining us at whatever time it is on your side because we have so many different time zones. I know it's now 4 a.m. on my side. I'm usually not up at this time for sure. But for those of you who are joining in and you took the time out, good morning, good afternoon, I think it may be good night at some point in time, but not too sure. But I see Matt Tossel coming in, Jacqueline George, good morning. Guillaume is here, Mohammed is here as well. So Matthew Moore is here. Yes, Matthew is very early on this side. I could definitely use some sticky toffee pudding, but that's for something else. Um, can't eat that this morning, all right, at this time, but I would definitely love to. So tell us where you're joining from, and we're gonna get LRVS started for the EMEA region. We have so many great speakers today. I've had the pleasure of actually seeing some of their slides beforehand, perks of this. And we have some really, really good content. I know Yo is joining us. Good morning, Yo. Thank you for joining us. And Guillaume as well. Good morning, Mohammed. Everybody's just now getting in, which is great because I know at this time we have so many people just excited for LRVS to start. We've been waiting the whole year for it. Jing, good morning. I see you jumping in as well. So glad that you all could make the time. And we have Kashif from KSA. Nice. We have a good mix. Munieva, Yilmaz, good morning. It's so great that you all could join us. I am so happy that you all made the time and you all are coming out. Anaz is here as well. Good morning, Anaz. This is our fourth year of LRVS, but it's not our fourth show because we started back in 2020 and then it's grown so much, because of this, because of you all attending, and we have such great speakers. I know we have John coming in. Don't worry, you'll be at LRVS for life after this one. So we usually do one big event per year. And last year we decided to split it up in the different time zones so that you all get more time and you all get the experience of the speakers, especially in your region or different regions. So it's so good that we can actually meet this morning and get everybody in. So I know Andres is saying good luck to Hadi, we have Hadi coming up. So some of our speakers today, we're going to start off with Dr. Abid. He is from Petrolube in KSA. And then we're going to go to Angus McDonald, our UK-based guy. And then we have Hadi coming in from Saudi Aramco. Then we have the huge panel discussion, which is going to be great. And we have a lot of experts on that panel. So it's going to be a very fun packed, very interesting LRVS. And without further ado, I'm going to bring on Dr. Abid in a little bit. He is going to be telling us all about some great things. So I'm going to get ready to bring him on the stage. And I know Assad is saying good morning. Good morning to you. Thank you for joining us. So let me bring Dr. Abid on the stage. Hi, good morning, Dr. Abid. He's going to help us and he's going to bring up his slides and start to present what he's talking about this morning because he is actually going to be talking about turbine oil monitoring and quality, how that leads to turbine reliability. So Dr. Abid is going to give us some
Okay,
good insights
good
into
morning and
that.
assalamu alaikum to everybody. You can hear me?
I can hear you very
Okay.
clearly.
And all the audience, today we are going to present practical case. Actually, we are the first lubricant plant in the Kingdom of Saudi Arabia, which was inaugurated by late King Malik Faisal Marhum. And we are operating in the kingdom and we are producing a lot of lubricant. And one of the product is a turbine oil. We are holding maybe more than 60% volume of Kingdom of Saudi Arabia in the turbine oil segment. So this presentation, which examine in the next 20 minutes to 30 minutes, will monitor and analyzing on the condition through a systematic way that can help identify turbine problem before they result in a major failure. So what happened? We have in the central region one of the big power plant where we and the General Electric, whose turbine were exist there, and we were supplying the lubricant turbine oil BG32 grade. It is a practical case in year 2010 when we receive a set of samples from the site, and in this, the first lab report, you can see this all the test parameter were quite good, except the color is showing light green, which is sparked to us, and then we systematically investigated. So this presentation will only give the the outcome of that how we smartly investigated and we avoid any breakdown or big damage to the turbine. And we find what was the reason of this blue color. Initially, I think come that this bluish is due to copper or something, but there was no copper in the solution. You can see some of the internal part of that turbine, how it looks at that time. It is a mid of year 2010 in one of the biggest power plant in the central region. We did along with the General Electric, since all these data I'm presenting based on the trust, it is not patented or it is not property of our, but it is a joint things, and we achieve something at the end result. So I'm just sharing with the audience that how if we do a systematic analysis of a customer complaint, we can adapt with some beneficial thing. Here you can see the problem turbine receive gradual losses of pressure in the hydraulic system. They're all this valve get choked and some pressure issues come up. In this slide, you can see the supplied oil color, which is a new lube oil color, and at 7,000 hours, something like a 10-month to 12-month operation, the oil turned to bluish. We have taken some of the high tech analytical chemistry help to analyze those of the varnish or sludge particle, and root cause was contaminated gel is a hydrocarbon product formed due to the varnishing. And I will not go in the all this detail, you can have it in the slide pack form after this presentation. We are again the first company who are producing with the Group 3 base oil since 2006. We start importing the Group 3 base oil from S Oil, which were partly owned by Saudi Aramco at that time in year 2005 and 6. And now it is 100% owned by Saudi Aramco, which refinery is in Onsan port in South Korea. And we are the first producing the high level turbine oil within the Kingdom of Saudi Arabia since year 2006. In this presentation, actually, the main thing we are suggesting a corrective action, preventive action due to some unwanted issue which was happened. We have a total investigation 125 bullet point, but I just capture here 25. And out of that, again, the used oil monitoring and this interpretation is the key of this success story. One of the main thing in this subject was a bluish color. What we did, we were asked to help identify the cause of the problem. We had never heard this problem except a case of Alstom turbine, which was 400 megawatt for a steam turbine here in the western region, where we had blue issues in the turbine oil color, which I can show you at the end of the slide. But that blue was a different means reason of having the color of the oil. So in the last slide, we will just we analyze electro spray ionization mass spectrophotometer to analyze these fine particles, and also we help these study with the FTIR and Fourier transform nuclear magnetic resonance spectroscopy to characterize the structure elucidation of this organic compound which was formed inside the turbine due to the weak acid remaining. We have find that often the big equipment is being cleaned at a pre-commissioning stage or commissioning stage or at a hydro testing stage with a chemical cleaning. Often oxalic acid, succinic acid, or some other weak acid is being utilized. So we able to develop some compound in the lab, and this is the top two structure. You can see the what we able to understand this Comasi brilliant blue dye is produced by Sigma Aldrich. The people who have a strong chemistry background, they know this is the dye available in the commercial market. So what had happened that due to that weak acid and some of the antioxidant in the oil which form the similar molecule which shows the blue color. Alkylated diphenylamine are commonly used as antioxidant because we were using a chemistry at that time based on Lubrizol different package, and we are able to you can see here the diphenylamine when react with the oxalic acid it produce some structure which was in the blue color. So we able to find the root cause through this dedicated study. And also we engage one of the company which is providing a very specific solution for the mechanical integrity is a key solution, deliver integrated solution product and services including root cause analysis. It is all mechanical. I am not involved in this thing, but since it's the whole study was two side. One is the chemical investigation, where I was directly involved, and the mechanical investigation, which was here you can see the problem station, the statement affected site has reported hydraulic pressure unit problem due to suspected issue with a sun cartridge valve. All these valve, these fine blue varnish particle were the reason of malfunctioning of this gadget. In conclusion, contamination was undoubtedly the source of failure of these hydraulic valve. Foreign contaminants restricted to the orifice and interfere with the flow mechanics prevent the valve from proper operation. Here, I would like to tell only one thing, that it is a conventional base, but nowadays artificial intelligence came. Not similar issue, but we were also selling to the military for this oil. So I had remember maybe 15, 16 years before when we sold our hydraulic oil to one of the combined military forces in Tabuk area, Kuwait Musalla, Saudi Arab, where they have a big simulator where our hydraulic oil were using. So these contaminants and these fine wear metal, which is a cleanliness level. When we supplied the oil to this turbine, it was a NAS 5, 6. And over the time when we receive after 10 months or 12 months the sample, the NAS was reached to 9 and 10. So we concluded that we need a short interval turbine oil monitoring, not like one has to wait for a long term and then this deterioration happens. So in the combined military workshop where we have simulator, we find an instrument which broken and a small particle from the wear metal. One can also find this metal is from which source, which part, and it is from bearing, it is from shaft or something else. So nowadays the analytical technique is more far above, which can help in helping the instrument operation. See, we send our oil to a lab is called Focus Lab in Thailand, and each used oil report was 7 pages. I cannot show here all, but two of the this gas turbine number one and number two before filter sample shows that on the right upper side wear condition was cautious yellow, and contamination was cautious, means the NAS level was increased from 5 to something like 7, 8, 9. And on the gas turbine number two, you can see here even the wear condition and the contamination was red. Red means you need to immediately shut down or you need to replace the oil. But oil condition remain in both cases green, means the physical parameter of the oil and the antioxidant remaining is in the fair form. In the old time, we were measuring the RBOT or RPBOT 2722, but nowadays, after thanks that we had this instrument from Flutech, I would like to thanks for Flutech for this seminar also, that we are now regularly monitoring our remaining antioxidant in our supply turbine oil for the sites, and we can gauge the situation in much advanced stage. This slide will show this greasy gooey type material from the turbine filters. You can see the left side is green and lube oil supplied was fairly color was less than zero point 0.5 as per ASTM 1500. This slide shows again some kind of means scanning electron microscope which we carried out in US for this study, which again proved that what happened in the oil due to some misoperation. Uh, in the last second line, the resulting loss of power was primarily due to the deposition of the pigment and the insoluble salt ahead by the gel ability to allow the mixture to be entrapped on the valve pressure regulator orifice, stick on valve sleeves and other surface, leading to system malfunction. We have also found that ill practices and non-compliance with procedure specific to GEK's reference mm, maintenance program was not unfortunately followed. So it was also the reason, which I mentioned earlier. The blue color was for means developed due to the weak acid and this antioxidant reaction, which we only prove that how this blue color achieve or is formed. So in conclusion, the turbine oil monitoring having a three part. Oil conditioning is one part. Often people are doing only on this thing, viscosity, RPBOT, VI, tan demulsibility, forming air release value of flash point, pour point, but oil cleanliness is a greatly affecting. In the last 2 decades, the research paper published on this one is saying that 85% malfunctioning of any big rotating equipment is due to the contamination or oil cleanliness, which can also be checked. The material wear is the third part, which is also monitoring is important. And healthy machine generate wear particle at an exponential rate. If the machine is operating in a normal, this linear relation, because the oil has a finite life, but it has a linear relation for the machine wear. But if something goes wrong, then exponentially wear start is rapidly as a parabola or hyperbola. So method of monitoring laboratory analysis, which we are doing in our Riyadh plant and Jeddah plant. We are operating three plant, by the way. One plant is in Jabal Ali, Dubai, one is in Jeddah, and one is in Riyadh. And we do have a mobile lab within the kingdom. One is in the eastern region, one is in the central region, one is in the western region, to support for the critical customer for all B2B who where our mobile lab having some instrument, and we immediately rush to the site where this problem, and then we send back the sample to our stationary lab. This is the one of the second last slide. You can see this is the Alstom, but I did not focus on this. Here again, you see on the left side, our oil was this. Is this is the story in year 2006 or 7. Our oil after certain maybe same 6,000 7,000 hours, it turned to bluish. When I visited with my team at that time, we find very immediately the culprit is this in the bucket type cartridge filter. These plastics or something which was on the filter, it was the reason of the blues. The blue color was leaching from there, and then we explained to the people from Alstom this turbine, and we addressed the issue because it is one of the reasons that total acid number in the turbine oil due to this antioxidant is sometime zero point 0.1 zero point 0.15, so it might affect on the plastics. So it is a good input to the manufacturer also, and they have revised this specs of the cartridge. With this, I'm just presenting that with professional and dedicated used oil monitoring will enhance and will help to the everything. And then not only the safety, it extended the equipment diet, reliability is greatly affected and saving the cost. So this is the takeaway point for the attendees. Proactive maintenance strategies can lead to significant long-term benefit. Employ both lab analysis and real-time monitoring can greatly enhance reliability. Regular monitoring of turbine oil is crucial for optimal performance. Thank you.
All right, Dr. Vid, well done. So I'm gonna remove this from the stage for a little bit and we could bring you all up because you had a very interesting PowerPoint presentation. Like the blue
I
was
don't know.
very,
I
the
don't know
blue,
if I manage in a time because you give a 20-minute slot.
yeah, you're still within the time frame. You're still good to go. Good to go. But I saw that the while the blue was very pretty for me, I know it was a problem having that color in the oil. So we do have one question from Guillaume so far, and he's asking what frequency of sampling and full used oil analysis reports do you recommend? I mean, of course, based on your experience and your wisdom.
Based on my personal experience and based on at least more than 80 turbines we were operating in the last 19 years with this organization, I would say that first thing you need to collect the oil and you see with the naked eyes. If
Okay.
with the naked eyes everything is okay, at least you can collect sample with the naked eyes by monthly basis
Right.
only. And for monthly basis, you can do the basic analysis like viscosity,
Ah,
pour point, flash point, something simple. And for every 2 months, you can do this RPBOT or nowadays antioxidant remaining
yes.
test is the critical parameter.
Mm-hmm.
And the cleanliness also, it can give you some with the naked eye. Once you see cleanliness level, you can monitor every 3 months or quarterly.
All right. I think that's some solid advice there. And I love the way that you presented the information in terms of letting us know exactly what you and the team did to try and
because
resolve
I
this
would
issue.
because I would say everything is a commercial impact. We don't want
Yep.
to make the life tedious for operator because if we put every
Yeah.
test for short frequency, it is not means it not give something. It's a fancy that you have
Yeah.
every short frequency such test.
Mm-hmm. Yeah, because the operators, they're the ones out in the field every day and they will know
So
definitely if something's
quarterly,
going
you
on.
can say, which is recommended quarterly is fair enough.
Quarterly is fair enough for those bigger tests, those more I know those tests are slightly a little bit more expensive than your regular tests. So your advice is quarterly.
I think the line was disturbed. I was saying that on a very rational or balanced quarterly test is fair enough. Quarterly means every 3 months.
Yes, definitely. So that's a thank you for sharing that with us. And I don't see any other questions from the audience, but I wanted to, just
One thing which I miss, I have to add, if the turbine is undergoing in a peaking, because in
uh-huh.
Saudi Arab, Alhamdulillah, we are greatly here. because of the petrodollar or something, there is no
Yes.
peaking because it's a steady operation. But if there is a peaking, that turbine going high and low, then there are some other frequency of some of the tests you need to revise.
Yes, definitely. And I know Yo is just coming in and he's saying for your steam turbines, steam and gas turbines, ASTM D4378, ASTM D4378 will give some additional information on your sampling frequency and recommended test. Thanks for that, Yo. Thanks for joining in on that. So I think that's a good question as well. Good content. Um, the stuff that you spoke about in terms of trying to identify how you all have like a root cause analysis and going through that process, how would you advise somebody else who is having a similar issue? What is the first thing that they should do if they have something like that occurring on their plant?
See, Sania, understand when we received this first sample set in July 2010, then it was very means severe to us. What was the reason? I
Mhm.
visited multiple time. I'm not means supposed to disclose the site here. It is a big power plant in
Yes.
central region. And but once we went with the GE team and we both work together and we achieve this thing, then it is a breakthrough. Even if I have authority or something, we can do some MS or PhDs on this subject.
Right.
This back simulation of this thing in blue color in the lab is something very is high tech, I should say,
Mm-hmm.
because
And
we not find a copper. I forget to share this report in the used oil. Once
mm-hmm.
bluish color in the lab, if people find, then people think copper sulfate or copper because copper is being used in some of the
Yes.
bearing or alloys in the metal. I'm not fully aware about the metal chemistry of all the parts, but the copper was zero. So we were more means bothered that why it is bluish, you know.
Yes.
Yeah,
It's a strange color. It's a good color, but it's a strange
yeah.
color. Yeah, and I have one person, Jed, is just asking, what would you recommend for varnish removal techniques?
See, okay, here my answer is something because all this world is finite. We cannot say, sometimes some people say life fill, but I do not believe. You can elongate this life of the turbine oil up to some extent.
Mm-hmm.
It is one of the reasons the celebrities are drinking the orange juices.
Oh my gosh.
Yeah, the orange juices having a natural oxidant, which is
Mm-hmm.
affecting directly on the skin and some of the aging process, slow down the aging process. Yeah, just for your information. So same thing in the turbine oil, we are adding antioxidant. So for free radical like oxygen, nitrogen, it will react and it will not allow to react with the lubricant molecule. So
Right.
lubricant will do but it can only extend up to some time. Once
Mm-hmm.
the varnish is produced, nowadays there are people, we do have that equipment is called, one company I'm not promoting is a Danish company, CJC. They have a kidneys filter and they are doing in some tank in isolation circuit, fix this equipment and they remove this varnish. Same like a dilation for the human. How do you do it?
Mm-hmm.
So this is the one of the varnish, but you cannot do anything by chemically to stop this.
Okay.
You need to replace the oil in a shutdown.
And we have one question from John. He's saying that they usually advise a routine monthly RPVOT, MPC, ruler, demultibility for steam turbines, either 4 to 6 months. Do you think that time is sufficient?
For me, since we bought this ruler equipment from your company, Flutech, we are heavily using this thing, and we are measuring the peak area
Uh,
because
yes.
peak voltammetry principle at a certain time it coming. We knows our turbine oil supply to which customer having
Mm-hmm.
which additive. So we return sample in the lab And once the used oil sample come to the lab, we compare with our original sample by
Uh,
superimposing the spectra, same like IR or something. So we know this thing. So my answer here would be 4 months.
Okay. All right. That sounds good. And I think it really depends on the criticality of your equipment and what you're trying to monitor. Definitely, if it's critical equipment, you want to make sure you monitor that as much as possible. If it's not as critical, you may have like a little more leeway to work with. But I think we are almost at our end time for your session, Dr. Abid. I am so grateful for you for sharing your information with us. You are a wealth of information. Anybody that wants to connect with Dr. Abed, you can do that via LinkedIn. Um, Check him out. Definitely, these videos will be going up on YouTube. So, whatever you missed, you can go and get a replay of it. So, Dr. Abed, I want to thank you so much for your time this morning. We're going to get ready for Angus in another 5 to 10 minutes. We will be seeing him coming in with his presentation. So, be sure to join us. We're going to take a quick 10-minute break and then we're going to come back with another speaker. So, Dr. Abed, thank you again.
So
And for our
thank you, Sanya. So thank
audience,
you, Sanya, for
you
you
are
and for your team also from
you're
my
most
side, from my
welcome.
management. Thank
Most
you.
welcome. All right.
Bye
So,
bye.
we'll see you all in a little bit. All right. We are getting ready for our next speaker. Our next speaker is coming in from the UK. Well, he's coming on my screen for now. Um,
That's it.
oh gosh, and it's always good to see you and always good to chat with you. You know, you always have so much good information to share.
Well, I hope so.
I hope, yes, yes, you definitely have good ones. I saw your presentation, I saw your slide deck. So I know
You're
you
very
have some really interesting things to talk about. And you're going to be talking about innovative and effective varnish removal for rotating equipment. And I know that was a question
welcome.
that we just had in our first session. So I know you're going to talk a lot more about that and go into detail. So without further ado, we have Angus with us, which is always great. I'm going to
Thank you.
get your presentation up on the screen and I'm going to pass it over to you because this is interesting because I'd like to see what the UK has in terms of the case studies and what they've been doing. So thank you for sharing that with us.
Tanya, thank you. A very early good morning to you
Oh,
in particular. Total respect. You're 4 o'clock in the morning in
very
Trinidad. Thank you so much to all the team at LRVS for the opportunity to present this morning. And a huge thank you to everyone who is joining us around the globe. I know primarily here in the Emea. But yeah, as Sanya kindly introduced, I'm going to be presenting a few UK-based case studies regarding a range of varnish removal solutions for, again, a range of rotating equipment. Firstly, a big thank you for Dr. Abid and his excellent presentation on turbine oil monitoring in Saudi Arabia. There's going to be a bit of crossover in terms of some of the case studies I'll be covering do also involve turbines. So just before we kick off, a brief outline of what I'll be presenting to you all today. Firstly, just a brief overview of my company, A&S International. Then we'll dive a bit into some of the varnish solutions we'll be discussing today before taking a more in-depth look at 5 particular UK businesses and some case studies around them before finishing up with a few key conclusions that we've gathered from those case studies. So firstly, who is A&S International? It's a business I founded with my brother Sean nearly 6 years ago here in the UK. I've got 20 years experience in the lubrication business. For many years, we represented a US lubricant manufacturer. And in the last 6 years, we've become a technical sales consultancy representing a range of machinery lubrication brands, and primarily via a global network of distributors. We work in more than 30 countries around the world, many of whom we've worked with for more than 30 years as an organization. Just very briefly, just a bit of an overview of some of the brands that we work with. These include our own private label, Mac Chem and Mac Lubes. These are maintenance chemicals and lubricants. The Viper wire rope lubricator, I think many people already know about. It's an Australian brand for the efficient cleaning and lubrication of wire ropes. Allspalita is a US bioremediation product for helping clean up hydrocarbon spills on land and water. Solnox Group are a British green tech with really innovative, eco-friendly, biodegradable fuel conditioners for reducing fuel consumption and also emissions. So many of the solutions have a key sustainability focus, and none more so than Fluorotech. I've known many of the Fluorotech team for up to 20 years now, the likes of Yo and Greg, and for the past 4 years, we've been representing Fluorotech as a master distributor, very proudly working in a number of countries around the world, including Philippines, Greece, Chile, Costa Rica, and also specifically here in the UK, which is why I'm going to be presenting today on some of these specific case studies in the UK market. Okay, enough about A&S International. We're now going to be talking a bit about varnish removal for rotating equipment. So before we touch on these case studies, what do we actually mean by varnish? It's a huge subject, one that Sanya and Greg in particular know a lot about. I certainly don't have time to cover it all in the 25 minutes I've been allocated. But fundamentally, there are dozens of different chemistries that make up these deposits, and they depend on a number of factors. Could be the operating conditions of the machinery or equipment, could be the formulation of the lubricant, and the contamination that influences fluid degradation pathways. But bottom line, varnish is an oil-derived deposit, and it generally comprises of soft and soluble organic compounds. And as you can see with some of these images here, these are taken from a variety of applications around the world. It tends to be a kind of brown, orangey, sticky substance you can see on these gears, on bearings and these reservoirs. But what I would recommend, bit of a plug, Sanya, but if you want to know more and understand more about varnish, there's a fantastic book that they published last year, Preventing Turbo Machinery Cholesterol, The Story of Varnish. It's got absolutely everything you need to know about this subject. So in terms of the benefits of being ahead of the varnish problem, it certainly pays off over time. So we've just got a couple of snapshot examples of just how significantly varnish can impact businesses. So starting on the left, $1.5 million. That was varnish on a thrust bearing that shut down an oil refinery. Nearly $500,000, again, a varnish on a bearing, which contributed to compressor failure. This time sludge on a filter, which caused a gas turbine to trip out. And then finally, even up to $60,000 for varnish on a valve spool that prevented a gas turbine from going online. So it really can have significant impacts on maintenance and operating costs for a variety of applications. So a bit of background about what Fluortek does as a business. And they have a synergistic suite of products which align with the Fill for Life concept. And there's four main areas. Firstly, the expertise, which includes Lrvs, which is where we are today, obviously, in fluid learning. Secondly, and really importantly, is the condition monitoring. The Fluortek team helped develop a number of key ASTM tests, a couple of which I will be discussing in a bit more detail today, including the MPC and the ruler. Dr. Abid mentioned the ruler in his last presentation, and they were designed to help monitor in-service lubricants, whether it's turbine oils, hydraulic oils, gear oils, etc. Thirdly, Fluortek also then developed a range of solutions for contamination control, which focus specifically on filtration that can safely remove varnish, which was a unique, innovative gel resin type technology, which can help to decontaminate systems. So that's the Vita ESP. And then finally, and most recently, a range of life extension products, which are technologies that are used to flush or remove varnish, as well as re-additize and rebalance in-service lubricants, which could be turbine oils, could be hydraulic fluids, compressor oils, even gear oils. So in this morning's presentation, I mentioned 5 case studies. What I wanted to highlight was the range of different industries and sectors. So we're going to be ranging from power generation to plastics, offshore oil and gas, and even an oil refinery. The applications include gas turbines, blow molding machines, air compressors. The lubricants understandably vary depending on the application, but it include turbine oils and also hydraulic lubricants. And the main problems we're going to be looking at involve high varnish potential and the subsequent issues that is causing, which includes high bearing temperatures and really expensive downtime. And then finally, on each of the case studies, we'll be taking a look at the solutions that we implemented to help solve those problems. And that includes both the MPC analysis, the ASTM D7843, as well as the Decon Solvancer and a couple of other products that we will also take a look at. Okay, to kick off the first case study, a company called Emea. They're a global business with obviously an operation in the UK, but also elsewhere, Australia, Germany, and Poland. Just over a year ago, Emea contacted us directly due to some issues they were suffering with their Solar Taurus 70 gas turbine, 2,000 litres of turbine oil in there. And the main issue they were suffering from was elevated bearing temperatures. Initially, they didn't know what the reason was, but the big problem with these elevated temperatures that the turbine was starting to trip out and they were having to operate it on lower loads, which was obviously a major issue for the plant and their productivity. Luckily, with the support of Solar, the OEM, they implemented an oil analysis program, which included the MPC analysis. And very quickly, they could see what the potential issue was. The MPC figure came back of 49, which is elevated and would indicate significant varnish potential. They contacted us. We had a number of meetings, myself, also Emea, and we discussed the application in more detail, had a look at the oil analysis, and it was very obvious to us that these elevated bearing temperatures were due to this buildup of varnish on the bearings, which was helping to insulate in the heat for the turbine, and meaning that they were having significant problems. So we suggested and recommended that they implemented the use of Fluitec Decon, the Solvanza product, which, due to the high level of varnish, we recommended a 5% mix ratio, which would require about 6 pails of product. They did so around Christmas last year, and again, with our advice, then ran a number of oil analysis samples in the weeks and months following. And a couple of things happened. Firstly, and most importantly, the temperature started to drop on the turbine, which ensured that there was no further tripping, which was great news for them. But as you can also see here, the MPC started to steadily drop and decline, and continue to then remain low and stable. And the team, with our recommendation, have continued with quarterly oil analysis to verify the continued stability and low level of the varnish. On this next slide, bit of a snapshot. Sorry if it's a bit small, the font, but you can see the original oil analysis here before they used the decon with the very high level of MPC at 49, but also in terms of the particle counts here, you can see why there was a warning sign with these huge levels, 25, 23, 16. We've then graphed this, as you can see how the MPC value has steadily dropped over the last 6 months. And then, as you can see here, once, and this was back in June, where the MPC dropped down to a 3. So a very happy customer. It meant that they didn't have to have significant downtime by having to drain out 2,000 litres of turbine oil. Just by simply adding this 5% of decon, they were able to solve the issue of these elevated temperatures. And here we are nearly a year later with no further issues. Secondly, we move away from turbines and onto blow moulding machines and the plastics industry. This business, Vaxax, down in the southwest of the UK, had issues with the hydraulic oil in these blow moulding machines. They visually identified what they then found out to be varnish in their reservoirs. X certainly marks the spot. You can see here, this is one of the hydraulic reservoirs, huge amounts of sticky varnish in the reservoirs. They took some oil analysis, and the MPC wasn't significant, but they also saw sticking valves, elevated operating temperatures, and based on all of that information and the discussions we had and the oil analysis, we were able to view, again, from our point of view, the best recommendation was the use of the Fluitec Decon. And again, we recommended a 5% mix ratio, which was about 3 pails of product. Almost immediately, they saw a good drop in the MPC. And more significantly, a couple of months later down the line, when they were able to visually inspect the reservoirs, they were completely clean versus what they had before. So again, for this business, the important element was that they were avoiding expensive downtime. Again, they were avoiding having to invest in a large amount of new hydraulic oil for their machines. And as I said, they were able to avoid downtime moving forward. Next up, and a different scale altogether, a UK oil refinery. So just over a year ago, this organisation approached us regarding some contamination issues that they had identified with their GE gas turbine. Due to the oil analysis program they had in place, they understood they had some contamination issues. The oil itself was nearing the end of its useful life, and they wanted to identify a solution that would effectively clean out the turbine properly when they drained out the oil, so that they had a clean system when they then added the new turbine oil. It became clear to us that a good opportunity and option would be the Fluitec Decon, to add it at a 5% treat ratio, but in a slightly different way from the other case studies we've already looked at. This was to be an actual specific flushing product. So they added these 2 drums of decon to the total product for about 2 to 3 months prior to the organised shutdown of the turbine, which is when they then drained out that oil And we knew then that the decon would have done a great job at helping to solubilize all the varnish of the internal components, meaning that the varnish was then removed when that oil was drained out, and meaning that when the new oil was added, it had a much better chance of long life due to not having any inbuilt contamination levels. So next steps for the client is to introduce decon to the new turbine oil to help prevent future varnish contamination, because that's the beauty with a product like decon. It can be left in the oil, it will prevent any future deposits, and we can always back that up with regular oil analysis, including MPC, to check that the MPC value is remaining low and stable. And then that can stay in the oil for the life of the turbine oil with no problem at all. Next, we're moving offshore. An energy company off Aberdeen with a range of solar gas turbines on their offshore platforms. As with, I think, all oil and gas companies, they have a very organized, well-implemented oil analysis program for their turbines, which includes the full raft of tests, including the likes of MPC and Ruler. And they had identified that on a number of these solar gas turbines, they had elevated MPC values. They didn't have the time or budget to replace the turbine offshore. And so again, we're discussing with Solar different solutions that could be available to them to help lower the varnish potential and safely extend the life of the oil. And Solar, as a business, referred them to us and Fluortech, and due to the success they'd already had with decon and other applications. And again, the decon for these large turbines was added at about 5% again, and we were able to see a swift reduction down to about an MPC level of 5, which was nice, low and stable. And that has continued during the last year. The business implemented a management of change, and the next steps is ideally to introduce the use of decon to other platforms and other rotating equipment that might be suffering from varnish as well. In terms of the next steps, other solutions that have also been discussed include the Vita ESP V100 filter units. These are relatively new in the last year. They were developed by Fluortech in conjunction with Solar Turbines. And why they are proving to be popular with the offshore oil and gas industry is due to the fact that they can be safely integrated into the turbines or the equipment's lube oil system. And there's no need for additional power, which can be a big issue for platforms when having to introduce a new solution, if they're having to find new power sources, etc. So this is something they're looking very closely at. As I mentioned briefly at the beginning, the Vita ESP is a unique gel resin technology designed specifically for removing varnish. So in this case, they've already helped to solubilize the varnish from the internal components. It's in the oil, but then once we can implement the Vita ESP, these filtration units will then strip the varnish from that oil quite safely. And then secondly, for some of the other applications, again, due to oil analysis results, we've identified by using the Ruler technology that Dr. Abid mentioned, they've identified that antioxidant additive packages are a bit depleted in some of those oils. So we're also looking at the possibility of using Decon AO, which stands for Decon Antioxidant, which through careful consideration and measuring, we can then replenish those antioxidant additive packages for the turbine oil, meaning that we can safely extend the life of that turbine oil and meaning that it doesn't have to be drained out and replaced, which would then lead to expensive downtime for these platforms. For our final case study, we stay offshore up in Scotland, some solar gas turbines, as well as some Siemens gas turbines and compressors. Again, this organization has a very well-established oil analysis program for preventative maintenance. Again, there was elevated MPC values identified. I actually met them up at one of the offshore shows in Aberdeen, and again, they didn't know what to do. They had these elevated MPC values, which they knew meant high varnish potential. They could see the elevated bearing temperatures as well, but they didn't know what to do in terms of, they didn't have, again, the time or budget to be having to drain out a lot of the oil. The rest of the oil specs were fine and in specification. So again, we are still in discussions with this particular organization, but the decon has been recommended and purchased. The first application will be a Siemens gas turbine later this year, once they've had to implement an oil change due to maintenance issues. That particular turbine's down. And then the next step is hopefully going to be some of the Siemens electrically driven compressors. We've got about 5,000 litres of oil in there. And the aim again is to introduce the use of decon there to be able to safely decrease the varnish potential. So those are the 5 UK-based case studies I wanted to introduce to you today. And just a few conclusions before I finish. Firstly, I believe the case studies have proven just how easy and effective it can be to not only identify and measure varnish potential by using the MPC analysis, but importantly as well, by then also confirming that solutions such as decon or Vita ESP have then done their job at successfully removing the varnish. For us, it's a very powerful tool, the MPC, and it's used by most oil analysis labs. We know it's something that we are recommending any clients with turbines implement it with their oil analysis program if they're not already doing so. Secondly, the ease and effectiveness of quickly and relatively simply reducing varnish contamination by using technologies such as the Solvanza products like decon, which is really important because very often it's not necessary to have to flush and drain out large quantities of lubricants if the rest of the oil spec is within specification. They're still fit for further use. So it's an easy implemented solution, no capex required, and as I've said before, it can be easily and effectively measured that it's actually done its job afterwards. Thirdly, hopefully you've seen the recognition and support that there is behind these types of solutions from really key OEMs. I've mentioned Siemens, I've mentioned Solar. Dr. Quick at Siemens has been a big supporter of FluidTech solutions because of the success we've had. Siemens actually list a number of the FluidTech solutions in their operating manuals. So that's been an important, because we're getting more and more of these referrals from some of these OEMs. And then finally, the Fill for Life strategy that I've mentioned and that we've been talking about in these case studies is really helping to prove that sustainability can be improved for a variety of companies by helping them reduce this lubricant consumption and also the CO2 emissions by safely extending the life of these lubricants. And that's really summed up in this Fill for Life model diagram here from the very start, the monitoring, reporting, the measuring with that technology we've been talking about, the consulting and the recommendations, and then the various actual solutions depending on the application and the operating conditions, whether it's replacing additives, replenishing additives, or removing varnish, or actually filtering out the varnish as well. Thank you very much for attending. Thank you very much for listening. I appreciate it. And I'm now available for any questions that you might have.
All right. And I think we actually have quite a few questions. Angus, you did really well. Thank you so much for sharing that information. Very interesting to see what's going on in the UK, especially with all of the things that we have,
Yeah.
in that particular area, because I know we have so many different sectors. You have offshore, you have power generation, you have all of these great things, and it's still being able to, do a lot of things. So I'm gonna jump straight to your questions. So
Okay.
we actually had Mohammed asking what components need to be added to the product to minimize varnish. So I think he's probably talking about decon being added to the different
Yes.
products. Yes.
Yeah, so I mean, the decon is one product. It's a Group 5 base oil component. It's just a fluid, no capex required. It can simply be added to the reservoir. So there's no actual components as such. That's the Solvanza products.
Yeah.
All the different decon products can just be simply added to the reservoir. So
And I
it's a simple
think
process.
you gave him a really good answer there with the Solvanza products. I
Thank you.
know Guillaume is saying, thank you so much for your great presentation. And what do you think about depth media filtration? Oh, Guillaume, of course you're going to ask about the depth media filtration. Definitely. Good question there, though.
I don't personally have a lot of experience with the depth media filtration. With the work I've been doing with FluidTech, it's always been to do with the gel resin, the Vita ESP, which is designed specifically for varnish removal. I do know that there has been some really good success with a variety of other filtration solutions. I know Delta Zero, for example, have had really significant success with their unique filtration technology in lowering MPC values fairly significantly. But as I say, my main experience, Guillaume, has been with the Vita ESP and the many case studies I've seen around the world with multiple different industries and just how effective it's been. Particularly with the team in Middle East, in Qatar and Saudi Arabia, they've had huge success with the Vita ESP and offshore platforms.
All right. And your questions are coming back in. So we have Jorge. Thank you, Jorge, for joining us. We know you on LRV, so definitely. What is the impact on the results when measuring MPC with equipment based on ASTM D7843 and equipment that is not and also used in facial makeup, typically used in laboratories? Trying to save that's a little bit of a typo there, but I think he's trying to just verify if you use MPC and you're measuring MPC
Yes.
in the lab, like how is that different from? I'm hoping he gives me some clarification somewhere, but how is that different from, I guess, being used out in the field in terms of physically?
Okay, so I think from what we're seeing, it's a much more accurate indication of the varnish potential. I look at the work my team did in Costa Rica, for example, with the
Right.
local power industry there. Again, they knew, as you've seen some of these case studies, they knew visually they had some varnish issues. You saw some of those photos, but then MPC is able to back that up significantly, very accurately from a laboratory perspective. I hope that
Right.
answers the question.
I hope so too. We have a quick question from John. Where does the varnish go when Deacon is used, Angus? I know this is
Great question, John. We get it asked all the time. It's not disappearing. The decon solubilizes the varnish off any internal components, and then it remains in the oil. But the way the decon works is that it then prevents that varnish from depositing out. So best practice would dictate, as I mentioned about the VTSP, once you've used the decon, we'd also suggest that you also introduce filtration, because then you remove that varnish from the lubricant. And that's what particularly a lot of offshore oil and gas companies do. They have the belts and braces approach. They use the decon, and then they also use the filtration to remove the varnish from the oil. But we also have many customers that leave the decon in the oil, the varnish remains in the oil, and we back up that point that we run regular analysis with the MPC to prove that varnish is not reappearing and redepositing on the components.
Definitely, because once it gets solubilized, it's not going to plate back out
Correct.
right away. So, good thing to know. That was a really good question. So we
Great.
do have another question. We have a lot of questions for you this morning, Angus. We have another question from Assad. He's saying, could you provide an estimate of the downtime costs and anticipated savings? This is a nice one. I like this one.
It's a great one. You might remember on my first slide, it was a snapshot of a case study that I didn't actually present because it wasn't UK based, but that was talking about an offshore platform that saved $2 million due to the implementation. I think it was a Vita ESP. As you can imagine, it's obviously going to vary industry to industry, but if we focus on the offshore oil and gas, we know just how expensive an hour of downtime is in the North Sea. They can't afford to have a turbine down for 3-4 days due to the reduction in production. But also even Emea, they're a plastics plant. But again, they had one solar turbine. If that was to go down for a week, the plant's down for a week. I mean, I don't know how much that would cost, but it would be millions of pounds again. So I think most of us know that, an hour of downtime in most plants these days is extremely expensive, because so many plants are running 24/7. If you lose that hour, you're never going to get it back.
True, very true. I have a quick question from Dr. Ovid. He's asking about decon and if it has a high degree of polar or non-polar characteristics of a chemical and might affect sealing material in the longer run. Do you want me to handle that one?
Well, it's a great question on an issue, but then you can follow up. We know through a lot of experience and expertise that it doesn't have an effect on the sealing material, and that's a question we get asked a lot, and guarantee that it won't cause issues with applications. And in that way, it's a very safe product to use and very compatible with a range of base oil fluids.
Definitely. And one of the things with the decon product as well is that it's based on the Hansen solubility principles. So it's while we know about the polar and the non-polar varnish and all of those great things, based on the Hansen solubility principles, it will dissolve the varnish easier because it has similar characteristics of the varnish. So that's why I'll keep it in solution. And it does not affect those sealing materials because of the way that it's been um, engineered, I would say.
Exactly.
So we have one more question from John, and he's asking if it would not be detected in the MPC test. I'm not sure exactly what would not be detected in MPC tests, but the MPC test would help you with your varnish
Yeah,
potential. It's
exactly.
always good to pair that with your ruler analysis because that
Yeah,
helps you to gauge what the actual what's going on in your oil in terms of antioxidants and if it's oxidizing or not.
yeah, and all the rest of the standard
Oh
tests that
boy.
we talked
Yes,
about.
all of
As, exactly.
everything else. You can't just use one alone. When you go to the doctor, they don't just do one blood test. They
No,
do all of them.
exactly.
Yeah. So that's how we try to keep it make sure we understand what's going on with the oil and we can do that and make sure that we have some idea. And you give us a great presentation this morning, Angus. We are just
Thank,
about out of time for your session, but thank you so much for sharing your information with us.
it's
It's
a pleasure.
always
Thank
good
you
to
for the
talk to you.
opportunity. You too, Sanya, and
All right.
well organised. Thank you for the opportunity, and thank you for all
Yes.
the questions, and thank you for listening today.
Yes.
Enjoy the rest of
Thank
the
you
event.
all so much for the questions. We are gonna have Hadi Katani joining us in the next 9 minutes. So stay tuned for his presentation. It's gonna be good. So Angus, we will be seeing you on the back end at some point in time. All
See you
right.
soon,
Bye
Sanya.
for
Thank you so
now.
much. Take care. Bye now.
All right, we are getting ready to start our next session, and we're going to be having Hadi Al Katani from Saudi Aramco with us this morning. I think it's still morning on his side. He will be joining us and he will be giving us some excellent information about AI and how can AI transform machinery lubrication programs, which is very interesting considering what we've had this morning so far. And I'm going to start sharing his presentation in a bit, and I'm going to bring him up on the stage so that we can hear him when he starts to present. So I'm just going to give him a little time to just get his mic sorted out so that we can make sure that we can hear him at this time. So I think we have him coming in. He's having a little trouble with his camera this morning, but that's okay. So I'm going to start sharing his presentation. Hadi, can you hear me properly?
Yes, yes, I
All
hear you,
right,
Sanya.
and I can hear you too. That's great. That means that this part works. So let me get your presentation up and just let me know if you can see on the screen.
Yes, I do.
And we're good to go with your presentation.
All right.
All right, looks good. All right, so this is what we're going to talk about this morning. So, Hadi, I'm going to give the floor to you, and it's all yours.
Okay, thank you so much, Sanya. First of all, I would like to thank organizers and attendees for their time. I'm really happy to be in this summit for the second time, and I'm looking forward to seeing this, event grow, with time. It is the right venue for the right people.
Oh, yeah.
It really make distances close and shorter. Thank you so much, Sania, for your preparation, coordination. This is really excellent.
All right.
Let me now, first of all, my name is Hadi Al-Qahtani. I am from Saudi Aramco. Um, I don't know if much about the company, but in oil, Aramco is an oil company. We have thousands of machine, and we have thousands of lubrication system for all different type of equipment with all type of lubricants being used in our company. Today, I will talk about the use of AI in lubrication business. And I think it's in line what the gentleman Angus and Dr. Abid has presented so far. I see very very homogeneous between the subjects, although we not coordinate with each other. But this is the topic of today. I will talk about AI and how it can transform the machinery lubrication programs. I will talk about some background, introduction. Then I will talk about the application of AI in lubrication. I will talk then about monitoring, prediction of lube oil issues. Then we'll talk about failures and how to prevent them, capitalize on the existing programs, and also the AI, which is the topic of today. I will talk about some challenges and benefits of having AI in the lubrication system. Then I will conclude with summary at the end. So in the next, please. This slide, I got some figures about the market growth for AI. I got it from our technology company in Houston. Um, in fact, the numbers are huge, as you can see. The global markets for AI is projected to grow by 2028 to 4.2 billion, with 90% share for oil and gas companies. I think this number it gives you how important the AI will be in the future for oil and gas. The global AI in oil and gas is expected to grow at 40% between last year and 2030. The big share of the AI is going to be in predictive maintenance, which is the largest market share, of AI in oil and gas predictive maintenance, which is represent about 35% of total market share. These figures are indication of the upcoming trend. I know some experts may not have big belief, or they may have some reservation on the AI, and is it mature? This is what we'll try to really uncover during this presentation. And I know I agree with them, but however, the advancements in this field is so quick, and it is getting better and better and more accurate as we go. So on the next slide, I will continue also talking about the growth, but in more zoom on the oil and gas markets. Sensor analytics is the leading driver for AI adoption in oil and gas. As more data is collected, AI models are getting better and able to make the prediction possible. The largest industrial AI currently region is North America, with Asia Pacific and MENA regions expected to grow and have the highest growth over the next 10 years. Saudi Arabia is the AI market is around 500 billion in 2022, and it's expected to grow in 3.4 billion by 2030. Thank you, Sania. The use of AI lubrication is getting increasing with time, and is playing increasingly role in improving the efficiency and the prediction and failure prevention in machinery. In fact, the AI technology is already being used and applied in machinery lubrication system. And below, as you can see, there are some examples by leading company like Scaife, Shell, Cortex, AI enhanced lubricant monitoring, Clover lubricants, Flowtech, predictive analytics, Mobile Surf lubricants, Luria Corporation, AI-based oil analysis, Siemens, Chevron, and Aramco. We have our, LCM, which is lubricant condition monitoring program. We start, implementing the AI. Next, please. In this slide, there is a comparison between the current or the traditional data analysis versus the AI approach. As you know, the traditional way of data analytics is rely on traditional dashboards that display data with limited interactive features. It provides a static view of the data for most users. Lean heavily on statistical analysis to generate insights and require analysts to draw conclusions. A significant amount of time is being spent for data professional to analyze. A human, they have some limitation, especially when you deal with massive and big data. And there is also possible, slow decision making due to the massive data being collected and analyzed by the human. On the other hand, the AI-based analytic tools can analyze large data, with minimum time and with decision making, process. timely and wider decision making. It accurately predicts anomalies better than human because the capability of these engines. AI-enabled dashboards also have the potential to respond dynamically to users with a personalized view. In the next slide, you see the current loop oil analysis program. This is just demonstration of what we have right now. We have the equipment management, we have the scheduling of samples, then we collect oil sample, then we send it to lab for testing, and the results get reviewed by the analyst. Then we make a recommendation or corrective action, and we issue reports at high level. In fact, this is what we have currently now. I will show you in the next slide what we are going to have in addition to the current situation. Here we have the current way of handling the lubrication. As you can see in the green arrow is the current one. However, with AI, you can see the blue arrow. This indicates the introducing of AI analytics. So if you look from the left, we have the samples sent to the lab, get analyzed and reviewed by the loop analyst. Then it will be shared to the plant, whether we have compliant samples or non-compliant samples. By having the online sensor, there are sensors right now are installed, but without AI, I know it's just take the measurements and tell you have water in the oil or you have contamination, and it will give alarm. However, the AI analytics tool in the middle, it will look into both the offline data or sampling data and also to the data coming from the sensors, and it will make the analysis. Then it will tell you this is good sample, bad sample, and this is the recommendation based on the result. And by the way, this methodology is applicable to all type of data. So, but since we talk here about the oil, I'm presenting the oil part of it here. So, the next slide, the AI really can do a lot for us. It can, help during the design of the formulation of the lube oil. Also, it will help in development of material selection, and also it is really a big adding value for the monitoring, diagnostics, and prediction. And this is the focus of today's presentation. I'm focusing on the prediction and the diagnostics part based on the AI. So it can predict, then analyzes based on real-time sensors, and it can also analyze the offline samples and data and suggest actions. Okay, and let me take you now back to the machinery failure and how AI can help in this aspect. As you know, there are some studies that indicate that 49% of equipment failures are due to poor lubrication management. Okay, so knowing this, introducing the AI, it can help. It can minimize this number by having timely analysis, accurate prediction, and heads up before the failure take place. This slide, as you can see, I just try to indicate how AI can help. We have sample KPI or process that manage the lubrication, from sampling compliance, failure due to contamination, as you can see, We have failure due to oil mixing. We have failure due to dissolved gases, and failure due to normal degradation. I believe AI can help in the failure due to contamination, because we have proven sensors now in the market that can really predict contamination. Also, it can help in the failures related to dissolved gases, because there are sensors now that can help. And also for, of course, for degradation failure mode, where the sensor can really help big time in predicting the degradation early enough to prevent a failure. Next, please. This is again, you are familiar with the FC curve. We have early detection. Lubrication is one of the best that predicts, failures early enough, before even vibration, before non-destructive testing like infrared camera, noise, or ultrasound measurements, heat, and so on. However, this is, if you can look into the curve, the lubrication analysis or lubricant analysis based on the current practice, there is a gap. Things can happen before a human can realize the issue. And here, where AI can play a role and advance the time or the prediction ahead. So it will, I'm expecting that the AI lubricant analysis, if you call it, it will be even before the dot, the current dot on the curve. It will bring it, before. So next, Sania, please. Yeah. However, with all of these, promises, and with all of these, anticipated benefits of AI, there are some challenges that we need to be, careful of, like the data quality and availability. Rubbish in, rubbish out. If you have, if you didn't have good data, if the data are unavailable, so you won't be able to use AI. The second challenge is the integration of AI with existing systems. Each corporation has their own existing systems built over the years, and having the integration, sometimes there are difficulties communicating with SAP, communicating with the existing maintenance, systems might not be easy. So careful, review must be done before adapting the AI. Also, the cost of, because it's not only about the AI engine. You need to have sensors. If you are looking for data analytics based on live data, you need to have people get trained, learn a new things about AI. So this is something that needs to be considered. Also, the AI is a little bit, could be complex for some people, so they need to understand the complexity of the AI models. Also the risk of cybersecurity. You are adding some tools to your network. It communicates back and forth. There could be some cybersecurity risk. Also the scalability and standardization. As you know, currently there is no, as far as I know, there is no standard that governs the AI in the oil and gas industry. Also, in lubrication, we still don't have a standard that mandates the use of online sensors. I also checked, with ABI. Still, there's nothing. I hope it will see the light soon. It is not like the vibration. The vibration is very well defined in the industry standard. Which machine you need to have, online sensors. Which machine does not need online. It just need offline, measurements. Same thing for lubrication. I think this is an area for improvement for all of us that we need to really to work on and make the requirement of oil condition monitoring, online condition monitoring, standardized worldwide. There is also a challenge, which is really, I'm afraid that, generation, will really lose the knowledge, because they will depend heavily on AI engines without knowing the basics of how they predict, how they work, So this is something that we need probably to watch out. The benefits of AI, I think I already talked, but this is just to emphasize more. It will provide it will automate the business for us. It will automate the repetitive and time-consuming tasks involved in data analysis. It will reduce the risk of human error, leading to more reliable and consistent results. It will really improve the decision making by improving avail the data, the respective recommendation for that failure mode. It will increase the productivity. It can perform tedious data analysis that take a significant amount of time for data professionals to complete. It is free from it will make them free from these tasks, so they can really spend and focus more on the most complex and impactful projects for their business. It will really AI can advance deep learning and machine learning models have the ability to more accurately predict outcomes than many of the predictive techniques we as a professional used in the past. It is providing dynamic and personalized interface. The dashboards based on AI are more interactive, more dynamics. You can really have better reporting, better representation of your KPI and data. In conclusion, AI algorithms can analyze vast amount of data to predict machinery health and reliability. That will help reliability engineers and analysts to make better and informed decision about machine condition. So again, this is proven. I have seen it myself in many installations, and algorithms getting improved with time. AI in lubrication, condition monitoring, and prediction is expected to grow in the next few years tremendously for both offline data, which is reviewing the sample data, especially if you have many installations and different type of oils, and of course for online data or sensors. There are key considerations, which is about some concerns that I maybe shed light already, but the workforce education about AI is really something that is considered to be a point for review and for alerting our people. Also, the data-driven culture. For data is fuels for AI algorithms. So invest in collecting and storing high-quality data across operations to facilitate effective AI implementation. It will lead to effective AI implementation. The cybersecurity and ethics, we need to prioritize, robust data security measures and adhere to the ethical principles in AI development and deployment. Partnership. industry like us, we need to collaborate with technology providers, research institutions, and other manufacturers to accelerate learning and share best practices for successful AI integration. With this, I conclude my slides and presentation. Thank you so much for your listening, and please let me know if you have question so I can help and answer them.
All right. So, Hadi, thank you so much for that very informative presentation. I learned a lot because I know AI is basically taking over everything. So, just like some of the points that you brought up about cybersecurity, training your people, I think training your people is very, very important. That's something that we forget about when we think about AI. We forget about the humans. I don't know why, but we forget that we have humans that will still be involved and that still need to interact with what's going on in the AI. So I know we have a lot of good questions coming your way. So I'll try to get to them as much as I can. And what I'm going to put up now is the first question. I mean, Yo is asking us about, of course, thank you for the very informative presentation. What is the role of standardization in AI development? Which I think is a big part that we have to look at.
Yeah, thank you, Joe, for the question.
Yes.
The role of standardization really it comes during deployments. So development, I assume that is something has been done already. But for deployments, we need to standardize, when to use AI solutions, which machine that will require to have the AI. We don't want to have it for all type of machines. We have critical A, B, C. I assume that we need to focus first on critical A machines. Then we can test it later on for lesser, critical machines. So we need to develop a standard when to use it. We need to develop standards how to really have the architecture of the AI into the maintenance daily work, into the operation, DCS, into their daily work. So currently, it's being implemented based on customer, best knowledge or background. But the standardization will help big time the end user to really adapt the right solution for the right application, and also make it integrated with the existing, maintenance and operation systems.
Yeah, and I think standardization helps in terms of trying to get everybody on the same page as well.
Yes,
So
true.
you have some level. So thank you so much for that question. I know Costin is asking a question about, is the install based on the assets um, enough to successfully run the AI models? Because I think we have a little bit of a typo there. But I think he just wants to know if we can really run those AI models based on, what we have in your assets. Or are there enough assets available? Thank you for clarifying that, Costin. Are there enough assets available to actually successfully run that AI program?
Good question, Karsten. Yes,
Good
there are
question.
enough, assets. For a company like us, we have really thousands of assets.
Mm-hmm.
So we have enough assets, to install this solution and try them. But
Right.
at the same time, there are many solutions. There are many, sensors. You need to select the right sensor for the right, application. So
Yes.
it's not the question is to me, it's not about the enough, assets or availability of assets. It is what you want and how you want to implement this solution into your assets.
Ah, okay. That's a good clarification. I know we have some other questions coming in, but I know we are almost out of time. So I'm just gonna go to Mohammed's quick question. Can we connect AI with our condition monitoring program? Which is, I think, a question that everybody has.
Okay, thank you, Muhammad. Honestly, the condition monitoring program is already mature, and the connectivity between AI and condition monitoring program, it will vary from application, from system to system.
Yes.
But there are ways, and I think the technology providers or the solution providers, they know better how
Mm-hmm.
they make the connectivity or the integration between the AI and condition monitoring program.
Yep,
For
definitely. And
example, sorry, Sania, for AI, deployment, for
mhm,
example, in vibration monitoring system, it collects, it talks to the vibration monitoring system and to the lubrication system, and it collects data. You need just to have communication between the AI, solution or platform into your condition monitoring system. It will collect information every minute or so.
yeah.
Then it will make the analysis. It will monitor the trending of your parameters. If something went beyond the norm, it will start monitoring, and it will send you notification.
Yep.
Hey, you have possible events coming to your way within 1 week or 2 weeks, for example. So it talks to the monitoring system. But the connectivity is something is not a concern to me. It can be done easily.
Hmm. Yeah, I think the connectivity I am worried about is a human part of it. Because even though we're getting the notifications, we need to make sure somebody reads it and somebody does something about it. So that's the part that we need to work on. So we are out of time. I know we have a couple more questions, but Hidi, I'm gonna
Sania,
ask you
Sania,
to. Uh-huh.
just I want to elaborate more about the notification since you brought it.
Yes.
I agree. I agree. You may end up with thousands of notification
Yes.
not attended. However, during our project, we have designed, we developed KPI, and also we made, escalation part of that. So if it is not attended
Ah,
within a time, it will go to supervisor level. If not attended, it will go to higher level, and so on.
okay.
So people will really will take care about these notifications.
That is good. That's good to hear. I like that. So we do have a couple more questions coming in, but I'm gonna have to ask you to help me out and answer those on LinkedIn for me as we get ready for our next panel, our final panel discussion for LRVS. But thank you so much, Hidi. Always great talking to you. Always great getting your knowledge, and thank you for sharing with us this morning. Still morning on your
Thank you
side.
so much. Thank
All
you,
right.
Sani, and thank you
Thank you.
everyone who attend and participate. Thank
Yes.
you so much.
So far. Bye for now.
Bye. Bye.
right. So we are just rounding it off to our last, very last panel discussion of the morning. It's been a very long morning, very early for me. So I'm going to bring on our presenters on in a little bit, and we'll have Dr. Carsten Gibler joining us from Spectralytic. Carsten, always good to see you.
Hi, Tanya.
Hi. We have Yo Amin from Fluidtech. Always good to see you, Yo. Thank you so much for
Hello.
all
Hello,
of your
Sanya.
support this
Hello,
morning.
Carsten. Good morning.
Hi, morning, Joe.
Hi. And of course, we have Rudiger Crate from Oil Doc. So I have everybody with me this morning. Oh, this is a good panel to be in.
Hello, good morning, Tanya. Good morning, Carsten. Good morning, you.
Morning,
Hello,
Rudiger.
Rudiger.
Good
Good morning, you
morning.
all.
So I know this morning we're going to be talking about the main question. Is oil analysis still relevant today? And since we've started a few hours ago, we've had so many great presentations with Hadi just rounding it off about AI and sensors. We had Dr. Abid talking about turbine oil, monitoring. And of course, we had Angus giving us some very good case studies in the UK based on what he's seen, what he hasn't, seen in the industry. So it's really good information that we've had so far. So I know this panel is gonna round it off, and we're gonna be talking a lot about, whether we think oil analysis is still relevant today. And I know this is not a one word answer for sure. Definitely not. And shout out to Angus this morning for, doing that plug with the book. And one of the things that you may not have realized about the turbo machinery preventing varnish book is that Yo Amin actually wrote the foreword. And in the foreword for the book, Yo talks about the evolution of oil analysis. So I'm gonna ask you to give us a brief breakdown of that. Like, how has oil analysis changed over the past 10, 20 years? Because I know you've been in this for some time. So I know you can give us some very good information on that. How do you think it's evolved over the years?
Yes, thank you, Sanya. Let me first of all thank you for making an excellent job today. It was already exciting. Um, you're doing that so naturally. So it's so we also see very good presentations. I would like to thank also the presenters, and you could see through the presentations also the expectations, the evolution on condition monitoring programs, the importance it plays, and so I'm very pleased that I can start off and this interactive session. Um, Also, I think yes. Well, let me tell you, 10 years ago it went very fast. I think Rudiger will certainly confirm that. If we think where we were 10 years ago, Rudiger, I think it would be just very interesting to look at that. But 10 years ago, I went back and I made a little analysis. 10 years ago, MPC was not even accepted as a method.
Oh,
Today, we speak in all the presentations. I hear people speaking about MPC, and it was the first time that MPC was introduced. I know at that time we were starting the standardization process of MPC tests. Thanks to a lot of laboratories, including, for example, oil check, where Rudiger was working at that time. The ruler method was implemented 10 years ago. It was starting to get a good acceptance level, and look where it is now. 10 years ago, 10 years later, it's very well accepted by OEMs, and I don't think there's an oil analysis report who's missing ruler analysis. Grease analysis. Look at 10 years ago. With think about Rich Woesbach, who was
yeah.
coming up with his first testimonials about the importance of looking at grease testing. I remember also a discussion I had with Rudiger on grease testing for like in paper plants in wind turbines, and where he also spoke about that. look the evolution that infrared has FTIR technology over the last 10 years has undergone. 10 years ago, it was used, yes, for some research applications, but today FTIR looking at oxidation, water, TBN, TN, it's a well standardized test method. So yes, I think, and on top of that, if you look 10 years ago, how education and certification has evolved. I would have not, I've never believed that it would have gone so fast. If you see STLE, ASTM, OilDoc, NORIA, ICML, ASTM, all bringing up these practices. So yes, I think the move from 10 years ago to now is, I would say, move away from pure oil analysis to condition monitoring, diagnostics, root cause analysis. I think that is the trend that I've seen over the last 10 years, and I think I've spoken enough now.
Oh my gosh, I can listen to you all day, yo, but I'm gonna ask Rudy. Rudy, like you've been in this industry for quite some time as well. How have you seen that evolution with oil analysis? I mean, you gave us a little bit of a insight there, but I know you have some stuff that you could share with us as well.
Yes, we have done a lot of work together with your presentations about the ruler and so on. But let me sum it up in a very easy way. There are two things I have to consider to
Mhm.
explain why this happens. We lubricate modern machinery. That means high downtime costs, high cost of the machinery itself, and the risk to lose money is much higher than before. That's the first one. But to lubricate this machinery, we use also modern lubricants and very, very long oil drain intervals. And that's the difference we have. If we only talk about the the better base oils we use, the saturated base oils, to have a better oxidation stability. But beside that, they have lost the ability to dissolve the oil aging byproducts. That means the
Mm.
increase of viscosity we have seen in the past, we will don't see it in
Oh.
modern lubricants today.
Hmm.
And even the increase of the acid number, the same story. That means the main facts we used in the to more or less to see whether we have oxidation or not, and all the things related to that, we have lost them. That's the first thing. And now, if you go to the analysis, I would say, therefore, the second thing is that we now uh, have to replace it, and we did it. Therefore, in my opinion, the main development strategy of oil analysis the last 10 years, but even the next 10 years, is the monitoring of the additive condition. Because of the base oils are more stable, very easy way. We have to have techniques to get the antioxidant level, for example,
Mm-hmm.
and other additives. And the next thing is sometimes people think we have better base oils, and because of that we have no deposits because of the yes, from the base oils, yes, but the depleted additives produce now the varnish and so on. And we will not see it in an increase of viscosity and acid number. We need not only the additive depletion to monitor using the ruler, the MPC. We need a technique to see the tendency of the oil to produce deposits, and
Yep.
and therefore that is the main driver today. And without that, it would mean, if we would work, to use your words, with the technology we had in the past, it's the same thing. We are driving on the highway at the night, and we switch off our lights. This we would do when we work like 10 years before. Okay.
Oh my gosh, I love that. Absolutely love that. And yes, I totally agree in terms of it's not just the oil analysis that we're going to evolve, the oils are evolving as well. So what we've used 10 years ago is not going to work today. Definitely not. And we have evolved, I would like to say. And that's why I like to bring in Carsten because I know Carsten is like heavily involved in the sensor world. And
Yeah.
you would have seen the changes in terms of moving from a lab base into the sensor world and into the sensor technology? And how has that evolved over the past 10 years? Because I know the technology we have today and that I've seen like working with spectrolytic, we did not have anything like that 10 years ago. Anything.
Yeah, sort of answering your question, I think, spectrolytic, we are a little bit late to the party. So I think we're sort of more focusing on the next 10 years to come. So what, as the previous speaker, Mr. Hardydorf pointed out, there is people want data. People want data and people want reliable data. The older generation that might know about the oils and the engines and all this stuff, that they're sort of slowly retiring, and younger generations are used to phones, tablets, and they need to have data presented in this format. And in order to do this, we inline oil condition monitoring sampling has always been there, but using data that are not really, I call them actionable. You can measure the dielectric constant, but what does a dielectric constant really mean in an oil type of thing? And so we really took the lead from the oil laboratories, where they use FTIR or whatever, where we really try to count the molecules, for not a better word, that are relevant to the application. Let it be the additives, let it be the stuff that causes oxidation, and try to provide this data to the customer so that they can use this data to make decisions, because that's what it's all about. At the end of the day, we are all trying to create to provide data that helps the end customer, basically to prevent unplanned downtime, because that's what costs the most money. That's what costs the most money. So, and what we are trying to do is not only provide a sensor, because I think the end users don't want to integrate sensors. The end users need a complete solution. They need a complete solution where they can ask you or tell you, I want parameter A, B, C, D.
Right.
And that's what you give them in the right format. And this is sort of where we see things going. And the closer you can provide data that matches the laboratory, which will always be needed, I think the easier it will get with what Mr. Hardy presented earlier on, to get all these AI models and the prediction and all this stuff. So that's how we see it.
All right, that's a good view as well, because I think one of the questions that always comes up is, will we see existing labs go away? Will there not be a need for them in the future? But like you explained, you'll always have the need for the labs. And Dr. Abed is actually asking a pretty good question here. He's asking if any analytical method developments to establish the correlation between TOFT versus TAN, MPC, and RPVOT. Well, don't hold back on us, Dr. Abed. Definitely, do you all see any sort of analytical method that could, do all of these together?
I think, well, it's a funny question. It's a bit of a funny question, and I think it's a little bit a way of how do you say, how we approach things. So there isn't a method. Obviously, in inline you won't be able to say here's a method for everything. But what sometimes works, so you can find oil specific solutions. Yeah, so we have oils where we get really good, very good correlation between whatever inline data and MPC and RPVOT. But then there are other oils where it doesn't work. But because we are working on inline installation, you only have one asset. And in this asset, they do not tend to change the oil every 5 minutes. This is so So once it's set up, it sort of works. But what we can't, certainly this is not our approach. We can't say, oh, here's a method that everybody can use, and this is how it works. So this is, I think, more one for Rüdiger to see whether you can
Yeah,
shut our
you know,
eyes. We certainly can't.
yeah, I work with oil analysis for 30 years. And when I sum up in the beginning to give them the right setup, more or less, I would sum it up in that case. There's no single method on the market
Yep.
covering all oil changes we will find in practice due to oil oxidation and what else, what happens there. It is not there. And every method has some special setup, and then we need a combination. We need a combination. We even TA and an MPC, there's no correlation. Sometimes yes, sometimes no. In RPVOT, we know even there are some special things. Therefore, we will have cases like you mentioned, Carsten. There we have correlations, and in others not.
Right.
And at the end of the day, very often even people in our lab ask me, we do the MPC for maybe per year several thousand samples, and if we sum it up, maybe only 20% are bad. That is a bad efficiency, more or less. I say no. Even to have the information, it's good. It's a reliable information, and we cannot say at the end of the day kick all these methods out, and we have at the end only one method covering all. We cannot have that, and therefore it will not work. Even online measuring and one very easy thing. We use the same sensor to measure particles by by laser sensor online in the machinery, and then they send a sample to us in our lab. We measure using the same equipment this oil, and we have different results. And sometimes people are wondering about that. I say it's very easy. You are measuring online, your oil flows, has a temperature of maybe 50 degrees C, and now we should online have the same result, but we have the temperature of 25. And therefore there must be differences. And but if we do it right, we know that the online and the offline data work good together. Because of, we know we have the higher results because of we have due to the lower temperature, we have other saturation level even for the oil aging products. We know that if you explain that to the customer, it's very easy. But to bring together that the online sensor has a very big advantage. You get the result within a second, and we can go to your equipment. We can take a sample. Everything is okay. We go to your office, maybe 5 minutes later, you have a leakage there. We don't have it in our bottle, and even 5 minutes are gone. It's not that much, but the sensor gives you the warning directly. Of course, the sensor cannot be that detailed like we do when we apply maybe 20 different methods in the lab analysis to give the picture. But he gives the early warning and can explain the main things. And if you want to go in detail, we need a lab. And this will be in the future even the same situation. The more we learn, the better. Other sensors are very clear. But I see the world very dynamically. There are that much changes. We have a lot of work even in the future.
We do, and we have a really good question here. Do you want to add anything to that?
On this question, no. I see there's a question who came
Yeah,
in
it
from.
is a really good question
Yeah,
here
yeah,
because
yeah,
I
yeah,
love
yeah.
this question from
Yes,
John.
it's the
Oh
question.
boy.
It's oh boy, yes, oh boy. It's the
Oh boy.
question.
It's one that I love definitely because ruler and RPVOT is something that we have going on in the industry all the time. People are battling with it. I mean, I definitely have a bias and I will say that, but that's just because I know in terms of your reliability with the RPVOT, and I'm gonna let you explain this a little bit more. But I think ruler and RPVOT measure two very different things,
Correct.
and that is why you would see different results. Your RPVOT, it gives you something in terms of the results in terms of minutes, which is not entirely applicable to what you have in the field, whereas ruler actually gives you a quantitative vision of your antioxidants. So I'm
Mhm.
gonna let you answer this question because I know this one is dear to his heart, and he's gonna help us. He's gonna help out our friend John this morning.
Yes, I think you answered mostly already, Sanya. If we go back 10 years ago, 15, 20
Yeah.
years ago, RPVOT, a test method was established in the years 1960,
Mhm.
mainly for steam turbine oil formulations to focus on phenolic antioxidants. At that time, turbine oils were using mostly phenolics for steam turbines, rust and oxidation, like they say, R and O fluids. From there, later in the 2000s, when gas turbines came on the market, higher oxidation stability was needed, and oil formulators were starting to blend phenols and amines, aromatic amines, as a synergetic mixture to give optimized oxidation stability. RPVOT values were then used as a method for new oil performance requirements, and you could see in 2004 with the new ASTM turbine oil requirements, they increased the minimum RPVOT value from 500 minutes to 750 minutes just to boost up the life of the oil. But an RPVOT test method, like you said, is measuring then the oxidation stability, and that is not only the antioxidants, that can be also some of the natural antioxidants, the base oil, basically. Um, the difficulty with an RPVT test is that, especially with new generation of fluids consisting of high amount of aromatic amines, gives high oxidation stability, means you could have like 2-3,000 minutes of RPVOT. Um, and The difficulty with that method is to see the drop of oxygen, pressure drop, detected by an RPVT method, which needs specialized, with really good interpretation, a specialist. Therefore, the ruler was, over the last 10-15 years, mostly replacing RPVT, also because of OEMs, which see that an RPVT test did not have the same repeatability as a ruler test method. But on top of that, I would say, like John is saying in his email, is that you need to make sure that they are using the right standards. And I see already an answer from Gwyn, from Polaris with the same answer, first of all. But secondly, more important, that the laboratory is trained well and is using the right test solution and measuring individual amines and phenols, because it could be that the lab is reporting a drop of phenols um, to till 10%, which is
Right.
pretty normal, and you could still have like 90% of amines. And not always in interpretation of the reports, the end user understands that this 90% of aromatic amines is what you need to look at, and that's also what ASTM standard is saying, that you need to look at the remaining antioxidant percentage to judge the remaining useful life of the oil. So there is mostly the confusion coming from, John, and I think it's also good to ask always your lab, and if I see labs, to show the ruler graph, see the graph and really understand, am I measuring the right antioxidants? That's in a nutshell, but in general, I would say the correlation is pretty good between ruler method or voltammetry and RPVT. That is, I think, and also don't forget the test method.
Yep.
RPVT is a method in minutes, 2,000 minutes. The ruler method is measuring in 20 seconds, just for a lab. You can imagine, and that's making the link to data generation. Let me make the link then to the question that the point Carsten and Rudiger brought up. Today in oil analysis, it's a matter of data, digitalization, like they say. So the more data you produce, you're going to be more powerful, and therefore I think the right test methods need to be selected.
Oh yeah. Anything you want to add to that, Rudy? I know you want to
Yeah.
add something to that.
Yeah,
Sure.
I want to add something. Uh, 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 we should have in our mind even the RPVOT. We test the oil with a bulk temperature of 150 degrees C. Even that's not the reality. Of course, we know that I'm a mechanical engineer and have special knowledge in tribology from the beginning of my studies. The testing, very often we have to shorten the time of testing,
Right.
and that we do temperature and oxygen. You know that, and or the load and the mechanical testing. What else we do? And sometimes, every time we have the question, is this method we use there the reality or not? Yeah?
Mm-hmm.
That means the more harsh the conditions are, the more or the higher is even the possibility that we even here are far away from practice. And now, one question I have to provide a training this 2 days. One question of one of the attendees. He asked me, what about the technical data sheet of a turbine oil? What I can learn from the data there? And then he, even here, he mentioned about the RPVT.
Right.
Huh? And he showed me a data sheet, RPVT, 3,500 minutes. What do you think about that? I told him, if I see that, I'm very critical that I will not judge about this turbine oil good or bad on one number. But if I see this high reading in RPVOT, I go to the other tests and I go to element analysis, to infrared, to see how this oil was done. Because of that, it is more or less very dangerous. If
Yeah.
one test is that high, that you have a solution, that you use a special additive package to have a high reading in the test, and in reality, you produce deposits without any end, especially in high temperature oxidation environment. And that's even here, we should even have in our mind. What I have learned in 30 years of oil analysis, put all values together and paint a picture. And only one test can lie very, very easily.
Mm-hmm. Yeah, and I totally agree with you because I know, and we spoke about it earlier this morning when we had a lot of the other presenters. We have had changes in base oils. We have had changes in lubricants over the years. They're going to be evolving. They're going to be hopefully getting better, but we will see those changes. And if our tests don't update according to those changes, then we're kind of measuring something from 10 years ago versus what we have today. So it's not an accurate measurement in terms of that. Costin, do you want to add anything to the ruler
Oh,
RPVOT
no,
debate?
no, no, that's well above my head.
Because I know it is a question that we always get. Everybody comes up RPVOT versus ruler. Again, RPVOT will give you a value that you may not be able to correlate in the field in terms of minutes. The ruler would actually give you what you have in your oil at that point in time. So I think that actually provides a little bit more value to what you're looking for in terms of monitoring your oil and what's going on with it. Yo, did you want to add something? I know
Yes.
you want to add something.
No, well, I think no. I would like to because the time is running. I think
Mm-hmm.
I want to continue on discussion that Carsten was saying, which was interesting. It's data. The future. The next 10 years will be important with the online analysis and detection. I fully agree, and also I would say that. Yes, the question comes from Mr. Mohammed Asim. How reliable is online monitoring system? My experience is that today I've pretty good experience with online monitoring. Think about water already, and I think viscosity. But there's new technologies which will be needed. Like Carsten will explain and already said about oxidation. Even I would say some of the possibility to look at antioxidant depletion online for critical equipment. But
Mm-hmm.
don't forget that I think online monitoring will be mostly important and needed by our end users, industry, as part of sustainability. It's clear that today, with what everything which is happening around us with the climate change and CO2 reduction, or challenges that plants have today to meet the CO2 reduction, that lifetime extension is going to be for lubricant assets, because they are an asset.
Mhm.
They're not a consumable. Let's change that mentality and making them an asset. The online analysis will be very important for that, to be proactive, on time, generate enough data, which can then be double checked by specialized laboratories, service companies, and then make sure that you come to an, I would say, a totally different approach and optimize the lifetime. So I think that is a suggestion I would like to discuss, and maybe then Carsten can answer the
Oh
question on
yes.
how he finds his
Yeah,
products to
no,
be reliable.
no, Joe, you are exactly right. So first of all, I always we get this question always: how reliable are an online monitoring system? You know what? The biggest problem with the current process is a human being. You know, somebody has to go there and take a sample. Somebody then the sample sits there for weeks. Then at some point somebody decides to ship it,
Mhm.
maybe.
Maybe.
Then it comes to the laboratory. So depending what the person has done the night before and whatever process they have run. So the human factor in all of this is by a mile a much the biggest influence on reproducibility in the lab process. So we have, we have installed our sensor. So we at Analytic, we do the mid-infrared spectroscopy type, and then we combine it with viscosity sensors, particle counters to really provide a complete solution. And the they have been validated by Exxon, by Castrol, by every end user, and they they match the laboratory results once they are. But that is not the point. What we are trying to do. So the what the lab people do, they produce what I call absolute value. As Rüdiger explained, you go time to time, you take a sample, you get it analyzed, you compare it to your OEM specification, and see whether it's still within the warranty guidelines and all these things. And these periods where you take sample, everybody wants to extend them because you have to send people to the engine, that's risky, blah, blah, blah. So what our center, what we are trying to offer is, which doesn't exist at the moment, is looking at the rate of change of a parameter, but looking at the rate of change of a parameter that's relevant, i.e. the oxidation, i.e. the additive depletion, i.e. the, I don't know, nitration, depending, like water. Depending, obviously, that does depend on the application. So, and the rate of change, how things behave over time, this gives you 100 times more information about what happens in your asset than an absolute value. An absolute value of 18 doesn't mean anything. But if you see, look, here is now an asset where it has increased from 13 to 18 in 1 week, and all my other assets, it increased from 13 to 14, then you bloody think, well, it's not quite right. But, and this is a fundamental difference where, and I think this is why the question, does it match the lab analysis and all these things, is this sort of happens automatically in a way, but it's not the purpose. We are not trying to replace a lab analysis, because as Rüdiger said, in a lab, he can bring in all his knowledge, he can do 18 different tests to really dig down. But by looking at the rate of change, looking at the range of change of parameters that the end user understands, because it's exactly the same parameters that they get from an oil analysis report, then they can really early on identify the assets where something is wrong. And then they can go to Rüdiger and say, look, Rüdiger, what is that?
Yeah.
What's the reason for this? Can you dig down? And then together we can work out how to improve things. But
Yeah.
this is sort of the thing that this is a new aspect that we
Yeah.
believe we bring
Yeah.
to the puzzle is the rate of change for each one.
Absolutely. I'm with you. And let me add something to that. Sometimes people think sensors work against labs. They don't do. They work perfectly
Right.
together if the customer wants that. Yeah, sometimes they don't understand it. I explain it even in my training this way. When we use oil analysis by a sampling technique, we can monitor very good slowly ongoing processes like the normal oil aging, like oxidation, like additive depletion and so on. Every time we have in our mind that the condition of change is more or less in a wide range, more or less stable.
Right.
Very, very fast changes we cannot have because of if we don't take the sample in the right time, we don't have it. The sensor can do that. And if you have a look to the past, very often I discuss with maintenance managers here in Germany. They tell me the following: if I go 10 years back, I had 10 people to do the work. Today I have two.
Yep.
And in the past, we did oil analysis and we did manual inspection. The guys went to the asset
Right.
to see what's going on. And now I have only two. We have to replace this gap. And sensors cannot only fill this gap, I'm pretty sure. If the sensors are well selected, they can do more than the guys going around and see the machinery more or less only from outside. They
Yeah.
can they can measure things from inside, and therefore I see there's no battle between the sensor and the labs. They work perfectly together because of the sensor can do things what we can't. And we can do with the right mixer, even clarify the details and the reliability of online monitoring systems. Yeah, there's an easy game like in the oil analysis. If you have only one parameter can you not tell you that much. And even that, and Carsten knows that, I love the infrared sensors because of the infrared sensor will not only test one wave number, but the right combination can do the job. And you can do it more wide if you say now the infrared and viscosity and this the more values we have, the better we can paint the picture and the more reliable is the
Yep.
picture we have.
Yes, and I think also what you're saying, I believe fully, Rudiger, is the fact that we have less resources in maintenance, so that they need to be better trained. And so it's important that that's why we have this LRVS, by the way, to make sure there's an online platform, learning platform. Next year in June, in May, we have Oil Doc in Rosenheim again to bring all the professionals together. But the training is so important, education of these resources, so that they are aware of already experiences today in the industry, and also how they can configure their programs to the future, because their input will be important. Because like you say, before there were 5 people,
Yep.
now 2. Secondly, I think the accessibility of some of industry. We see, for example, and I know labs today are very active in the wind energy to monitor the gear oils or the pitch control hydraulic oils. Well, that is another good example of where online sensors are already used today, but will be more used because the accessibility is so difficult. Or think about a nuclear plant or subsea applications. So I think there is really a wide range of applications. Last week I was speaking to people, operators in the mining, and they say for us it's always a mess to take these samples and send it out. So if we could have at least, like Rudiger is saying, a signal when things are suddenly changing, then we can take action. So it has so much benefits, but the oil analysis still today, the condition monitoring, the basics, where I think we struggle still with is that the financial benefits. We need to maybe Sanya, you want to address that
Oh
subject?
yeah, for sure. And I think a lot of people, a lot of plants, they're doing cutbacks. They're doing, they have budgets in place and they're like, they can't spend too much money. And they think that it's too much of an investment to do oil analysis. But when you really think about it, the benefits of doing oil analysis, of catching that failure early enough, can actually save you millions. And I know we spoke about that earlier this morning in one of the other presentations. Once we have critical equipment, being able to catch that you have a trend in change, because at the end of the day, oil analysis is always going to be that. It's going to be trending the changes that we have in particular parameters. And once we can trend that and make sure that we keep it below the alarm levels, you can maintain your equipment. You can, remain running. And that's the justification that you will have for actually implementing oil analysis. Or in some cases, if you have a little bit of extra budget, you can do those oil sensors and, actually put those in. But they definitely have to work together. Unless they work together, then we're not going to get the full benefit and the full value that they can offer. And I love what Rudy and Costin are saying in terms of, everybody has to work together, the labs, the oil analysis sensors. So I think from our audience so far, one of the things we should take away is that we're not doing an either or with oil sensors and labs. We have to work together with these. And as we evolve, as technology evolves, we need to start getting up with the times, for sure. Get up with the times and, upgrade your facility, upgrade the equipment that you have, because the oils are changing. Your values are going to be different from 10 years ago. So you can't use those same, reference values. And I know somebody talked about that in the comments. If you're using your baselines, make sure it's the most recent ones. And that's another thing with oil analysis. I know Gwen was talking about that. Thanks, Gwen, for pointing that out. Make sure you have the most relevant and the most recent samples, because with condition monitoring, you're always going against your baseline. You need to know what your baseline is. That's the first part of it, because that's what you're comparing is against. So I wanted to talk a little bit about machine learning. And I know Hadi covered some stuff about AI a little bit earlier. What do you think? And he broke it down very nicely earlier on. How do you think we can do AI with sensors, Carsten? I'm
But I
asking you
think,
that one.
I'm not sort of the AI expert, but I think it's the, as Mr. Hardy said, rubbish in, rubbish out. So that's sort of the fundamental thing. So obviously, so what we are trying to do with our sensor or with our solutions is to provide what we call actionable data. So we give as an input meaningful data, i.e. a particle count, an oxidation value, not a temperature or a pressure or the color of socks that the operator is wearing, that you then all throw into a huge database, and then you run some whatever models over it to get correlation. And I think in a lot of cases, this is what's happening at the moment. People have loads of data, they throw it in a database, and run algorithms over it, and out comes a correlation, as Mr. Hardy pointed out, and then who understands why this correlation exists? It becomes harder and harder. So, and I think in order to do it, that was also my question about the installed base, I think you need quite a lot of assets and data to do it. So because we are sort of providing more or less sort of the same type of data as an oil laboratory now. So in my head, you can combine our sensor data with historic oil analysis. So, and suddenly you have what I call sensible data, sort of chemically relevant data that you can put into your AI model and combine it, so that the overall, if you talk about money, the overall cost of setting up a model in terms of how many training sets or whatever you call these things you need. You have all the training sets because you can go back 30 years in your whole analysis if you want to, and you can combine it with the inline sensor where you now get a reading every hour or however you set it up.
Mm-hmm.
I think this will have a huge impact on the acceleration of using AI or machine learning type systems, because the data are now they mean something.
Yeah.
You don't. In the olden days, it was mathematics. Now it's called AI. Interpolating these things out is relatively straightforward, and then you combine it with all the other algorithm types that might be there. But that's sort of my take on it. But I'm not the AI expert.
We had
Let
the
me,
AI expert before. Rudy, I know you want to say something about that.
only a very short note as a mechanical engineer. When I started my studies, one of our professors in technical mechanics, how to calculate maybe the dimension of a machine element or what else, and he told us the following: you want to become an engineer, you need you need to create models how you calculate something. And at the end of the day, you should be able, if you have the result, to have a feeling or a knowledge whether I can trust this result can be true or not. This is very important because if you can calculate many things by numbers. And I think we produce, even in our lab, and especially if you use sensors, such a big mass of data, we cannot do it manually. And the data they are worthful. Even in our lab, very often I explain customers, hey, if I go back in history, I see your machinery the last 10 years. I see that changes in trend. I see that something is different than before. I can see it in the trend. Other problems maybe are the same as before. And you have to use data to do that. And at the end of the day, again, we cannot do it manually with the mass of data we have today. We need help. But we should be that intelligent at the end of the day to have a look at the results, to see whether they are good or not to say this is a good or bad technology. That's not the question. To learn together, to apply it better, to have at the end of the day the better result. But we must do it.
Yes, definitely. And again, we have to work together at the end of the day. You, I
Yes,
know you want to add to that.
equipment are also becoming more demanding.
Yeah.
Let's
Yeah.
not forget that. And it's not just turbines, but we are more and more involved, for example, with manufacturing. See how today automotive industry is changing face with this whole EV transformation. But the quality requirements. The just-in-time delivery availability of components is today so critical. If you produce, think injection molding machines and your components that you produce, aluminium components for aerospace, today they're all fighting to get all these components in time in the airplanes. I think there it's clear that AI will be going to be important. Think about if you could combine the need of production need together with the criticality of machines and the delivery delays that are going to be created, depending on the data which is produced by the performing of the machine, the performing conditions. I think it's vast, so vast, and I think oil is only this little piece. But let's start with that already, because like Rudiger is saying, and Carsten, there is a massive amount of data already available. My point is, which companies are going to be the leading companies to be having that data shared? That's I think my only question I have, because the data, no doubt, it's there. And there's a lot of universities, and so there will be the challenge and bring companies work together on platforms so that then we can make sure that we take the maximum out of this AI. And but yes, in 10 years' time, Sanya and Carsten and Rudy, we will be back hopefully on the same platform, and we can ask ourselves, do you remember 10 years ago we talked about where
Yeah.
condition monitoring and AI will be? I'm 100% committed. It will be a success.
Yeah,
Absolutely. I have no doubt about that.
Yeah.
absolutely.
Yeah, and I think one of the things that we're seeing is that AI is able to actually do a lot of the things that we could not have done before. Just as you mentioned, there's a large amounts of data out there, and now we can actually collect the data and store it in a particular place and actually use it, have models to run on it. So I know Carsten was talking a little bit about that before, and Rudiger, you as well. So I have a couple people like just joining in, and they're saying, why wouldn't anybody want to do oil analysis on their plants? You need to know the condition of your operating machinery. Of course you do. It's a small price to pay just to, find that out. And I know Matt had to drop out for a little bit, but we've had a lot of good comments so far for the morning. Just want to do a final round of wrap up thoughts on the oil analysis topic that we're talking about today, because it is very relevant. We've seen it, we've talked about it. It definitely is something we need to combine with oil sensors and
Mm,
AI and machine learning. And I feel like every other technology that's going to be coming out in the next 2 or 3 years, because the
mm.
rate at which we are evolving is going to be different for sure. So, what do you think, as you started off with the question, how do you think we can actually change this in the next 10 years, or, have something? No, I'm just giving you can look into your crystal ball a little bit and tell me what you think it looks like in the next 10 years. And Carsten, I know you're at the forefront in terms of sensor technology. How do you think your sensors are going to evolve in the next 10 years? They're already
So
small, so
no,
they can't get
no, I
smaller,
mean,
right?
they are not small. They are small. They are small. As I think from our side, so we are going to add more. We call it laboratory equivalent inline sensor solution. So the next thing we're going to bring out is an inline elemental
Okay.
sensor, so that you can do elemental analysis inline. Again, within reason,
Yep.
within reason. So to provide more and more actionable data that forms part of the puzzle of the puzzle. But I think the biggest problem in all of it is a little bit with the end customer. That if the end customer has has an oil analysis budget and only looks at it at the oil analysis budget and doesn't look at the overall uh, product life cycle cost, for not
Mhm.
a better word. Uh, and I think there are different companies that function differently. There are some companies that are more progressive, that sort of have a wider view, uh,
Mhm.
but there are still a lot where at least we see, why should we use a sensor if an oil analysis costs, I don't know, whatever, or whatever it might be. Uh, so it's missing the point a little bit from our side, but there you can't really say anything because they are right. But again, we are adding we are not doing an oil analysis. We are adding additional information but if the
Right.
end customer doesn't see it like this, that's that's a fair point. But I think this change in attitude of saying, look, here is a critical asset, as one of the guys said, why wouldn't they do it? But a lot of people just don't care, or that maybe they do, but not enough. So
Not
that's
enough.
what what why I think where things need to change a little
Mhm.
bit. But it's an overall. I think we all have to prod the end customer and point out how important it is to look at sort of preventive stuff.
Definitely, Rudy. I know you want to add to that. Where can we see oil analysis in the next 10 years? based on everything you've seen?
Maybe oil analysis has to do less routine testing, routine analysis, but more be the key for clarify the details, what happens in practice. When we work together with sensors, by the way.
Yeah.
Yeah?
Yeah.
And even we in our lab will use those technologies to do more with our data, to be at the end of the day more efficient, even in recommending actions and increase reliability. That is very important. What we have we have to do, and if we can automate a little bit better the way of sampling and information sharing, therefore we have our app in development, and we use it, of course, for years to make it more smart, to bring not only the sample in the laboratory, but the right information to have the basis to do it right. And then I'm pretty sure we are still in the business in 10 years, of course.
For
But it will be
sure.
more smart.
I'm sure you will be.
For sure. And you, rounding off thoughts on this one.
I can only add, I think fully agree with Rudiger and Carsten,
Mhm.
especially Rudiger, what he's saying, that we should go for more specialized oil analysis, for root cause analysis. Also, think what I was saying about sustainability, lifetime extension. If you want to assess the oil quality, is it viable for lifetime extension? Do you want to add another 30% of the lifetime of the lubricant so that you can avoid interventions, increase liability, reduce the risk, because we all know that every oil change is always
Yeah.
containing a certain percentage of risk. If you can avoid that, and also once again, think in function of sustainability. I think oil analysis will be driven by these requirements from CO2 reduction and footprint reduction. So I found that, and their own online sensors will be absolutely playing a major role.
Mm. And a very short note, and we sum it up what we discussed even in this hour. But we have to take our customers with us, and their education is very important. That is only
Absolutely, I
very
could
Oh,
not.
important.
Rudiger, let's make some promotion here for Oil Doc next year
yes.
in May.
Maybe we
In
have this conversation in
Yeah,
person in Germany next year
yeah,
in May.
yeah. So that will be absolutely education. I could not agree more. Thank you.
Definitely. So, guys, thank you all so much for your time this morning and for sharing all of your knowledge because you all are the top ones in the industry. I'm glad that I was on the panel with you all and you all, made the time for me this morning to do this and to share with our audience as well all of the information on oil analysis. I think a lot of people got very important information. If you took anything away from this panel, know that condition monitoring is where you monitor changes in your oil. So it
Mm.
always goes back to that, making sure you have a proper baseline to compare against. So thank you guys so much for all of our audience that joined in from all over the world, Singapore, Malaysia, the European region, people who got up from the Americas. I'm sorry that you all had to wake up so early. But thank you all so much for just joining us and always being a part of LRVS. This is our last LRVS for the year, and we will be back next year, 2025. And we will be looking forward to seeing you all here again. So, stay tuned. All of these recordings will be available on YouTube. It's going to be available on LinkedIn for the rest of the day for sure. And
Mm.
just keep looking out. Connect with all of our speakers. So, another thank you, very quick thank you again to Dr. Abid, to Angus for joining us, and of course to Hadi for sharing so much great information with us
Thank you,
today. So,
Sanya. Thank you, Sanya,
Thank you.
especially for hosting, coordinating, and having this
awesome.
panel. You did a fantastic job. So
Thank you so
thank you
much.
so much. Wonderful.
No,
Always
thank you
Tanya,
very much.
for you.
thank you.
Okay.
All right.
Thank
So,
you very
Bye,
much.
everyone.
Carsten,
Thank you.
Rudiger,
Bye bye.
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 Take care. Bye.
Bye.